Hi guys, welcome back to my channel. So in this video I'm going to show you how to find the work done by the force which is given by this function along the curve y equals to x to the power of 4 between these 2 points. Alright, so this is the formula to find it. So the work done is equals to line integral of the function f and dot product with the derivative of this vector function. Okay, and this is a little bit complicated formula. You can still use it, but it's a little bit lengthy, because here you will need to draw this this curve like x to the power of 4, and then you'll need to draw this and then find the integral using the intervals of the x and y. So this is a little bit lengthy, and I believe it's not practical. So I'm gonna show you another formula to find it, and I find it quite easy. Okay, so here this is the formula. So you're going to treat the function as the gradient of the function, and then you're going to dot product it with the derivative of the vector function. So the steps that I'm gonna follow in here, it's gonna follow this formula over here, and then you will arrive at this at the answer to this question. Okay, so let's do this. So first of all, since we're finding we need the gradient of the function. For this, we need to prove that the function itself is indeed equals to the gradient, because to make these formulas equal, we need to make sure that the function is equal to the gradient, right? Okay, and for that you need to show that the vector field is conservative. If you cannot show that the vector field is conservative, then you cannot use this formula. You need to show first that the vector field is conservative to be able to use this formula. Okay, and how do we prove that the vector field is conservative? Here we have two variables function. So here, if you guys remember in the curl function, the curl video, I told you guys how to find the curl of f, right? For the 3 variables function, you had an equation, right, to memorize, and then you need to show that the curl f is equals to 0 or not. If it's a 3 variable function, that you need to show that the curl f is equals to 0, and here we only have 2 variable functions, so I'm not gonna go ahead and show that the curl f is equals to 0. If you want to know for the 3 variable function, then I have made the video already on that, so click here to watch that out. In here we are finding 2 variables function, right? I and j, there's no k hat. So for this we need to show that q of x is equals to p of y. So if you have not following my Cal 3 playlist, then you guys might be confused that what is q, x and p of y, right? If you're new here, then let me explain real quick what is q, x and py. So here, when you're finding the curl, you're assuming the first variable, the I hat, the x component as the p, and the y component as the q. Okay, and if you have the z component, you treat it as r. So here we only have p and q. And here q of x means you're differentiating this with respect to x. So this simply means partial derivative of q with respect to x is equals to partial derivative of p with respect to y. So these two are the same notations, but just written differently. Okay. Okay, so like here, q with respect to x and q and sorry, this has to be p with respect to y. These two are exactly the same notation. Okay, so let's go ahead and find q of x first. Okay, if you guys find it a little bit difficult to memorize this, then just remember, for the p, since it belongs to the x component, you are simply taking the derivative with respect to the other variable, right? Because this belongs to the x component, you're simply taking the partial derivative of this with respect to y, and this belongs to y component, so you're taking the partial derivative of this with respect to x. So the variable that it belongs to, you're simply taking the other variable and then taking the partial derivative with respect to that. So it's just a little trick to memorize this thing. Okay, let's continue the problem. So p of y, right? Okay, which means we're partially integrating this p with respect to y. So x is a constant over here. Okay, so 2 of x, that means it goes to 0, right? When we take the partial derivative of this, so this is 0 at the first, and then this, the partial derivative of this is the same thing, and then we need to divide it by the inside function, the partial derivative of the inside function. Okay, and this is -1, so it becomes this. Oh wait, I forgot, it's not divided by, it's multiplied. Division is in the integral. Okay, so you divide it, so you multiply it with the inside function, the partial derivative of the inside function. Okay, so the inside function is -y, and we're integrating with respect to y. So the derivative of y is -1 because it's -y, and it gives the same answer. But I just wanted to clarify that we multiply it by it, not divide by it. Okay. So what's next? So we have q of x next. Q of x, partial derivative of q with respect to x, that means y is treated as a constant. So y goes to 0, and then this x is 1 because the derivative of x is 1, right? And then the constant stays over there. Okay, so we have this e to the negative ey for q of x, and what do we have for q of y? Oh, I already wrote over here. So p of y, we have the exact same thing, which means that it's proven that the vector field is indeed conservative. So make sure to write it, because otherwise your whole answer is wrong. So you can say therefore the vector field is conservative. Okay, so now since qx equals to py, okay, now what do we do next? So once we have proven that the vector field is conservative, this is the first step that you have to do. Okay, so the next is the calculation of the work. Okay, so to find the work, first of all, what you need to do is that you need to take the function itself over here that we wrote over here. Okay, so I'm going to rewrite over here the function x squared that is 2x plus e to the negative y I hat plus 4y negative x e to the negative y j hat. Okay, so this is the function over here. So here you guys, since you guys have proven that it's a conservative vector field, we know that the function now is the gradient, right? So this function that we're given here, it's not the function anymore, it is the gradient. Okay, so this is the gradient, not the function. Okay, and if you guys remember taking the gradient is simply f of x I hat, f of y j hat, and f of z, I mean, sorry, f of z k hat. Remember? If you're confused with the notation, then it's simply partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z, right? Remember, guys? So this is what the equation of the gradient means, right? Okay, so I'm gonna remove the other notation because these notations are the same. Okay, And here we do not have z, we do not have the k component. That means here we only have f of x and f of y. So this is f of x and this is f of y. So here, once again, this is f of x and then the other one is f of y, which is nothing but simply the partial derivative with respect to y and partial derivative with respect to x. Okay. So now, once we have the gradient, how do we get to the original function then? So to be able to get to the original function, what do we have to do is that we need to take the integral of this function, right? Okay, so what we're going to do is in here, we have the f of x, right? Here, the function with respect to x, f of x, right? So we are going to take this function over here, 2x plus e to the negative 2y, and we know that this function is the partial derivative with respect to x, and when you have the derivative and to undo the derivative, what do you do to undo the derivative? I guess you guys know that to undo the derivative, we need to integrate it, right? And since it's a partial derivative over here, we need to take the partial integral. And here we derived it with respect to x, so we're going to integrate it with respect to x then. Okay, to be able to get the original function. Okay, so we're going to integrate, partially integrate with respect to x. That means we're treating y as a constant over here. Okay, so what is the answer to this then? I'm going to write it at the bottom. Okay, so this is going to become 2x squared 2, and this is going to cancel out, of course, so we're left with x squared only, and then this is a constant, and we're not going to make it 0 because we're not integrating, and we're not deriving it, we're integrating it, so we're going to add an x over here since it's partial integral. Okay, and when you integrate, you of course add a plus c at the end, right? But in here, instead of adding a plus c, we're going to add plus g of y, right? And you might be wondering, what is g of y in here? And where does this come from? Okay, so you want the exact function, right? And the function, to get to the original function, we only integrated one part, the f of x, but the f of y still remains to be found, right? So to be able to find the y part, we're going to replace the constant by g of y. G is simply an arbitrary variable. You can name it whatever you want, but usually we write it g. Okay, so g of y, because the other variable that we are missing is the y. Okay, so this is almost your function, but we're only missing the y part. Okay, so you can just circle it, so you're going to come back to it later once you have found the g of y, and then you're going to make the write the whole equation all by itself. Okay, so now our job is to find g of y. Okay, so here g of y is what we are looking for, right? And how do we find the g of y? So for that, here you guys see f of y here. So we have the f of y over here, right? So we already have the function with respect to y, the derivative of the function, the partial derivative of the function with respect to y. And here we have the function. So what about if we integrate this function with respect to y, and then we make it equal to this one? Because we already have the f of y. And what about if we integrate it with respect to f of y and then make it equal and then find what is missing, right? I don't know if that makes sense, but let's do it. I'm pretty sure after doing it will make sense. Okay, let me change the color if it's not that visible, the green color. Okay, so right, so we're going to integrate this because we're missing g of y, so we need to integrate this function with respect to y. Okay, or you can say it f of y, it's the same notation. Okay, so that means we're treating x as a constant over here. So x is a constant, this goes to 0. Okay, and it's a constant over here, so it's gonna stay over there. And what is the derivative of this one? Like I explained before, it's the same thing and then multiply by -1. So this is simply going to be negative x e to the negative y and plus. Now what is the derivative of this? It has y, so it's not a constant because we're deriving it with respect to y, so we cannot make it 0. It's not a constant, so we're going to like make it to the derivative, right? So g prime of y, because we don't know what it is, but we know that it's something with respect to y, so it's just a derivative with respect to y, so g prime of y. Okay, so now we have g of f of y over here, the partial derivative with respect to y. So now here we also have partial derivative with respect to y. So now what about making them equal? So let's make them equal to each other. So here this is what we found from the f equation, the function, and this is what is given to us, 4y negative x e to the negative y. Okay, now let's cross out what is equal. So this part is equal, so it is crossed out. So what is g prime of y then? It is equals to 4y. So we have found our g prime of y, but now wait, we didn't find g of y. You guys see here? We were looking for g of y, but we just found g prime of y. We didn't find g of y. So what do we do to get the g of y then? So for that, let me recall again. What do we do to undo the derivative? Yes, you're right this time. So we take the integral of the function to undo the derivative, right? So we're going to undo it. And what is the variable that we're integrating with respect to? So we're integrating with respect to dy. But why dy? Because we are finding g of y, and we know that there's only one variable involved, y. So that's why we are differentiating with respect to y. Okay? And this is a simple one variable integral, not two variable partial integral, since only one variable involved, not two. Okay, so this is simply 2y squared. Okay, so now you guys have 2y squared, and you guys might be wondering why I didn't write the plus c over here. Here you write the plus c or not, it's the same thing, because eventually it's gonna be removed after when you find the work, so you don't have to write it over here, but if you want, you guys can write it over here. Okay, so it's 2y squared. Okay, so now what did we just find? So we just found our g of y over here, 2y squared. So now let's go ahead and plug the g of y in this equation that we just found over here. So our final f of x of y equation becomes what? It becomes x squared plus x e to the negative y plus 2y squared. Okay, right? Plugging into the g of y that we just found. Okay, this is the function that we just found. But this is not the final answer, because our question was to find the work done between these 2 points, right? Find the work done. So now we have the function and we have these 2 points, 0, 0 and 1, 1. So what we're going to do, so I'm just gonna write it over here, okay? So let me separate it. So for this, to find the work done, you're going to take the point B and plug it into this function, and then subtract it and plug the point A into the equation. So our point A and B are simply 0, 0 and 1, 1, right? So let's say this is the point A. The first one is the point A and the second one is point B. Okay? So we have 0, 0 and 1, 1 as point A and point B. Okay, so now plugging in the point B into the equation first, that means x and y both are 1. So 1 plus, this is 1 and e to the negative y. So e to the negative 1 plus, this is 1, so this is only 2, and then negative, and now we're plugging in 0 into this equation. So this is 0, and the whole thing is 0. So we're only subtracting 0 once. So now if you add this, so that is 3 plus e to the negative 1, and this is the final answer, and this is the work done by the force. Thanks for watching. And also, if you want to do another problem for practice, I have made another video, and you can check that out in the description and watch it for practice. Thanks for watching. Bye.